In the name of God, in this session, we would like to talk about tie set method. Tie set is the complement of the cut set method, but it is used less frequently. Cut set is the best method for complex systems. Tie set does not directly identify the failure modes of the system, but cut set works with the failure modes of the system. It has some spatial applications and is discussed briefly in this section. A tie set is a minimal path of the system and is a set of system components connected in series, i.e. a tie set fails if any one of the components in it fails, and this probability can be evaluated using the principle of series systems. As you see, in a bridge system like this, A, C, B, D, how many passes from the input to the output we have? One pass is AC, another pass is BD. Here you see first tie set is AC, the second is BD. Each of these components fails. One of these passes will fail. OED is another pass, BEC is another pass. Tie sets are in parallel. All of the tie sets are in parallel. So, reliability of the system is the probability of having a complete pass in each of the paths. For example, if T1 is okay, we will have a pass from the input to the output. If T2 is okay, or T3 or T4, we will have a pass from the input to the output. So when we want to compute the reliability of the system, the probability of having a pass from the input to the output is PT1 plus PT2 plus PT3 plus PT4 minus PT1 and T2. This is the formula, the expansion of this formula. This formula can be expanded like this, and the last part is minus PT1 and T2 and T3 and T4. PT1 is the probability of ST1 to be correct. So it is RA multiplied by RC. PT2 can be written as RB multiplied by RD, etc. As you see here, PT2 RB RD, PT3 RE RD, PT4 as RB RE RC. To the last part. If you substitute each of these RA to RE by R, we can reduce this formula to this. And for example, you can use this number for the reliability of each part and compute the result. The difference of tie set method and cut set method is that in the tie set method, we cannot use approximation in the evaluation. Why not? Because if we use approximation, for example, in approximations, we omit these parts and we only calculate PT1 plus PT2 plus PT3 plus PT4. As you saw before, in the cut set method, you can use the approximation because the reliability after using approximation will be less than the real one. But here, if you use the approximation, these parts are subtracted from this. So, if you use the approximation, the reliability calculated will be greater than the real one. And your calculations cannot be used because, for example, you think that the reliability of the system is 0.98, but the real one is 0.9. And this calculation is not okay because you want to use these calculations as a basis, for example, in your contract. In some contracts, for example, in the military contracts, the reliability of the system is mentioned in the contract. Here, we don't have something like that. But in a perfect contract, you should mention that you buy a product, for example, with what reliability? For example, you say that I want this product, but with the reliability of 0.99. And after test, if you see that the reliability is 0.98, you can activate the punishment mentioned in the contract. As the calculations of the tie-set method, the main disadvantages of the tie-set method is that calculations cannot be approximated to a set of summation terms as was possible in the case of cut-set method. Because when we use approximation, the results of reliability of the calculation should be less than reliability of real system. If you have this condition, the approximation is okay. In the cut-set method, we have this. But in the tie-set, it is reversed. The reliability of calculation with approximation is greater than real reliability of the system. So we cannot use approximation, and for this reason, we don't use tie-set method in the most cases. Another method in this chapter is a connection matrix. In this method, a connection matrix is constructed from the system network or reliability diagram. I showed you in this example. As you see in a bridge system that we have introduced before in this chapter, we have 5 parts A, B, C, D, and E. And as you see, we have a connection diagram. From the input, we can go to A or B. From A, we can go to the node 2. And from the node 2, we can go to node 3. And from the node 3, we can go to node 4. Or from the node 2, we can go directly to the node 4. We can write a connection matrix from this figure. We have 4 nodes. Node 1, node 2, node 3, and node 4. From the node 1 to node 1, it can be written as 1. From the node 1 to node 2, we have A. From the node 1 to node 3, we have B. From the node 1 to node 4, we don't have any direct path, so it is 0. From the node 2 to node 1 is 0 because we cannot go back. We cannot go back, so it is 0. From the node 2 to node 2 is 1. To node 2 to node 3 is E. Node 2 to node 4 is C. Node 3 to node 1 is 0. Node 3 to node 2 is E. Node 3 to node 3 is 1. Node 3 to node 4 is D. And node 4 cannot go back to none of these nodes 1, 2, 3. And they only have connection with itself, which is 1. So we have these metrics. We see unidirectional branches and bidirectional branches. Bidirectional branches is like this, from node 2 to node 3 is bidirectional, and from the node 1 to 2 and 1 to 3 is one directional. Also 2 to 4 and 3 to 4 is one directional. And bidirectional branches. Node removal. We want to transform our matrix to a 2 cross 2 matrix, which only involves input and output. In this example, the node input and output is 1 and 4. So we should reduce these rows and columns. How we can reduce these matrix to a 2 by 2 matrix? The method is as follows. If we want to remove a node K from a matrix, each element Nij must be replaced according to Nij prime is equal to Nij plus Nik Nkj, where Nij prime replaces the old Nij. If we want to use this method for the removal of the node 2, substitute 2 for K. For example, for N11, we can write N11 prime is N11 old plus N12, replace 2 for K, N21. N12 is A and N21 is 0. So we have N11 as 1 plus 0 is 1. N13 prime is N13 old plus N12 N23. Okay? N13 is B, N12 is A, and N23 is E. So we have B plus AE. B plus AE. Another example, N14 prime is N14 old. N14 old, how much is N14 old? Is 0. N14 old is 0. Plus N12 N24. N12, how much is N12? Mustafa? Yes.